Are we all there? So you all have this curve, right? Each one of you got a different data, but basically what you see is probably in blue dots you have a Y display, position versus time, and in red dots you have X position versus time. Now, why the X position for most of you doesn't change with respect to the initial data? Why the X position, the red one, seems to be a flat curve? It doesn't curve like the other one. It doesn't go up and down like the other one. Why is that?
Isn't it just the total distance covered?
Say it again?
Isn't it just the total distance covered?
Yeah, basically it's just going a vertical direction. Ideally we should have this displacement of Y versus time in such a way the ball would go up in a vertical and down without moving laterally, right? So the red point should be flat, should be at the same level, which means the position of X with respect to time shouldn't change. So here you see a little change, because the ball is kind of moving a little bit to the side when you are throwing, but once the ball is up in the air, it should be more or less flat, which means today we are not going to derive any information in the X direction. We are all there? Okay? So we are deriving information for our Y versus time graphic. Okay? Now, a bit of information before I start playing around. So you can go here in your component, in your labels, click on any of them and select only, for instance, Y. And then you have only Y in there. You don't need to have the two of them. You can later on, it is asked you to analyze the Y velocity versus time curve. So you come over here, click on it, and then you have your Y velocity curve displayed. See that? So let me go back to position. There you go. Now, right in the beginning, after we've done that, evaluation of data, it is asked to examine the graphic Y position versus time. It appears to be a curve, fit a U-shaped curve to your data. So here on the command bar, on the top command bar, you have a U-shaped icon. You click on it, and then what you want to do, you want to fit a quadratic, this one. So you select a quadratic. Why is that? Well, I could select a third degree, fourth degree polynomial, fifth degree. The problem is I don't know any laws of physics so far that gives me position versus time as a polynomial of third power, or fourth power, or fifth power. But we learn about second power. So I'm going to try to fit that one, and I get this model. Oops, sorry. And I'm getting this model here. Now, is this model, the one that I just showed you, fits the data? Is it fitting the data? Yes or no, maybe, I don't know, I don't care. Which one would you choose? Oh, it does? 50% chance of being right. Yes or no? Again, does it fit the data or not? No. Why not? Well, so you see this line over here in the left-hand side does not fit this point. And certainly the model in black is not passing through the curve. So why is that? Well, I have the ascending part of the ball, I have the descending part of the ball, but I also have a shoulder here. That means what? What is this? What is the shoulder here representing? What? The initial what? Which part of the experiment was this one? You're still holding the ball. So the ball was there, you're holding, and you were giving a push on the ball up. So you do have an acceleration here, right? Because the ball is being accelerated. The ball was not moving, and suddenly you guys shoot up in the air. Especially my friend, where's my friend over there? He brought a soccer ball, so the ball was going all the way. My dean came down and said, "What the heck are you doing with these balls?" Because he's in the second floor, he's seeing this ball just going up and down.
Really?
Yeah. So what is going on? So you saw George, the guy who was talking to me, kind of a huge guy. Yeah, he said, "Oh, the deal. Oh, what are you doing with the ball?" So this is not part of your your experiment. You don't care for that, do you? No. So let's take that part out. How do we do this? See this bracket over here? You left click on it. See the icon change, your cursor change, and then you move a little bit to the side. So make sure you are including points that the ball is free up in the air. Now, what do you think about your fitting now? Is the model fitting the data? It's much better, huh? So it looks very good. Look at this. It goes through all the points. Here, I don't know. Probably she got a text message when she was clicking this point, she got distracted, and then it went down and over there. Okay, so I like to take the brackets, the region that I'm fitting points, I like to make sure they are off the extremes. So this is a good fit. See that? Now, I could play around. I could decide if there is a difference between ascending curve, which is also very good. See that? If you bring the bracket all the way to the top, you have a very nice fit to your ascending curve as well. And if I bring the brackets now, oh, I was not able to, there you go, to the descending part of the curve, I realize there is also a nice fit. I can fit well all the points in the descending, but not in the ascending. See that? So you can fit well the entire curve, and then you get what we would call average value for ascending and descending. But I can also fit only the ascending part and get a data for my upward acceleration, and I can also fit a descending part and get a data for my acceleration descending route. Are we all there? So you can play around. You can be very flexible here. Are you all good? Good? Why not? Yes? Okay. Now, question number 10. Write the equation that describes the y position versus time behavior of the ball in each segment, the ascending and descending part. So we have two parts here to consider, the ascending and descending, and we are going to use an equation for each one. How do we do that? First of all, I have to be able to erase the board so I can write on it. What is my So there is an ascending part, there is a descending part. So let's work on the ascending part only. So I bring my cursor, place it in there, and now I'm modeling the ascending part only. Here are the coefficients. So y is equal, and I'm going to write only with the two significant figures. Negative 4.3 t squared plus 14 t plus In fact, minus 9.1. This is what I got in my model for the ascending part. Are we all there? In my case, so your case is different. So I want to analyze that, right? So I know that y is equal vt plus half a t squared y is equal y naught, or y minus I naught is equal vt plus half at squared. So this equation of motion we learned in our course. We are learning this. So when you compare this equation with this equation, what can you say about acceleration? What can you say about initial velocity for the model and your data when you look and compare those two equations? Here is your physics, and here is the model that fits the physics of your experiment. So what can you say about, let's say, your initial velocity? According to your model, what is your initial velocity? What? Right? Got it? And according to the model, what is your acceleration? Oh, sorry. What's your acceleration? Your acceleration is? So negative 4.3 is equal to what? Negative 4.3 is equal to what? Don't look at me. It's not in my face, I swear. So look at the two equations. So negative 4.3 in my data, not in yours. Yours is going to be different. Is equal to what? Thank you. Say it again.
1/2 a.
Louder, so everybody can hear.
1/2 a.
1/2 a. Therefore, can you derive your ascending acceleration from here? Your ascending acceleration is, if we multiply both sides by 2, is negative 8.6 meters per square second. That's, according to the data, that is the ascending acceleration in this data for this group. And when you do the same analysis for the descending part, you find the descending part has a bigger acceleration. So twice of this number, 10.2, is your descending acceleration, which makes me go back to the group and figure out what they do, because that's not what we were expecting. Just a second. All right, so that's the data for the group. The group had an acceleration going upward that is less than the acceleration going downward. I want to see if you guys get the same. Okay? Any question? Are you okay now with the analysis you need to do? how you kind of go in real world and get information and try to get physics information out of it. Are you okay with that? Good? All right. Let me give a tour to other groups. Let me see what you guys got. So what is your ascending acceleration? The ascending acceleration is what?
So this one right here, negative 9.64.
And the descending?
I haven't done that one.
Oh, you have done that one?
But
Okay. What is your ascending acceleration? Do you have it?
Yeah, the sun.
17.8?
Yeah,
Something is wrong. And what is your descending?
descending.
15.4.
Yeah.
Okay, the ratio is consistent. You have a bigger one going up in number, in magnitude, and a different one going down. I wonder if your scale is correct. So let me check now your scale. And that's how we go. We keep just moving around and make sure everybody has some good number. Okay, bye.